All right, first question. Parker, you got it open on your screen there? You want to read the first one for me? All right. It says, if two rectangles have the same perimeter, do they have to be congruent? Explain how you know. Well, hopefully, if they have the same perimeter, do they have to be equal? So here we had the same perimeter, and obviously you can see that they are not equal. So that's a perfect example of it right there. You could even draw those two over here and say, here's two examples that have that. But your answer is no. And I'm just going to put see page 93, and it demonstrates that for us. And of course, if it says explain, Gavin, we need to do that. Okay? Draw two rectangles that have the same area but are not congruent. Leighton, you got two examples?
I did like a rectangle facing up and down and then one side to side.
Okay, did you label the sides?
Yep.
What do you got?
The long sides I did 4 and then the short sides I did 2.
And what'd you do on this one?
Same thing.
Okay, that would be congruent though, if they're exactly the same. So, same area, so if this is area of 8, I could do this one, area of 8, then they're not congruent, right? They have different sides. Just because they're twisted, if they're the same, both 2 and 4, that would be congruent. Okay, for each pair of shapes, decide whether or not they are congruent. Explain your reasoning, all right? So the first one, are they the same or are they congruent? And explain. I don't know. Anybody trace it? It's one way to know for sure. What do you think? Yeah. Yeah, it is. Why? I traced it.
I couldn't trace it.
Why not?
I didn't have tracing paper to trace it.
You could just use normal paper. It works the same.
I have very bad eyesight. I can't see through normal paper. I'm stacked.
Let everybody know that Gavin now has tracing paper that is no longer an excuse. B, what do you think on that one? Yeah, if you trace it again, it's going to be exactly the same. We're going to go yup. We're going to change it up a little bit. Exactly the same. I traced it. Trust me. 4, reflect A over the x-axis. Label it and reflect it again. Looks like we should have 2 drawings here for those of you that only have 1. Looks like you only did half. Reflect over the x. All right. Dot it up. Connect them. Label it B. Kind of hard to see. There we go. Reflect it over the Y. Okay. There's a Y. Dot it up. Label it C. Done. Are quadrilaterals A and C congruent? Explain how you know. Ian.
Yes.
Why?
You trace them.
Yeah, it was traced. As long as you have tracing paper, it makes it pretty easy. Question 5. -2, -3 rotated 90 degrees counterclockwise. Actually, let's just use the bottom one here. It's already drawn for us. -2, -3, that's right here. We'll just cheat and use this little handy dandy pad they have there for us. This point right here. Around the origin, let's see, counterclockwise would be this way. So what point is that at?
3, -2.
3, -2. C. 6, describe a rigid transformation that takes A to B. So starting with this guy, I need to get to B. Now, more than one way to do so. What do you want to do? Well, I'm going to call this point 1. And I'm going to take that to point 2. So I'm going to slide point 1 to 2. So from here to here. And then I'm going to rotate 180 degrees. Don't have to say which direction because it's 180. Again, a lot of different ways to go about that. But you need to get from point A to B. Just make sure you describe, because it said to describe what you did. And maybe you did a reflection, slide, and then rotate. That's fine too. Completely up to you. Questions?